Okay, this video is about intro to equations and Vedic math way. We will use some sutras here, and it's video number 10. Main sutra being used here is transpose and apply. Let's continue. Are what's an equation? Where do equations come from? Word problem and equation. Think of a number. Reversal method. Transpose and apply, and solve simple linear equation. Okay, let's discuss the equation. What's an equation? Equation represents equality or equivalency between two quantities. And these two quantities are separated by an equal sign. Let's continue here. Where do the equations come from? Equations arise from all sort of real and imaginary situations. In almost every field of studies, there are equations. Okay, field specific equations. Some examples are in physical law. Okay, here is force equals mass times acceleration, comes from Newton's laws. Here is energy equals half mc squared, that's Einstein's theory of relativity. Let's continue. And identities, there are also equations given by a plus, which are identities, and which is a plus b equal square equals a squared plus b squared plus 2ab, where we evaluate left side in terms of right side, and it's valid for all real values and of a and all complex values of. Continued. So if we can have a word problem and we can represent that in a equation as an equation, at least some problems we can represent as an equation. So here is an example given by word problem. Three friends had a few berries. They put the berries in a basket and went to sleep. So I'm going to narrate a story, and in the end we'll have to figure out how many berries there were. Okay, let's start. First friend got up, divided the berries in three, ate one third, and put the rest into the basket, and went to bed. So what happened is he ate one third and put the two-thirds of the berries back into the basket. So after he was done eating, there were two-thirds of the berries in the basket. Let's continue here. Second friend got up, divided the berries in three, ate one third, and put the rest into the basket and went to bed. Now, after second friend got done with eating, there were only two-thirds of the berries. Now, third friend got up, divided the berries in three, ate one third, put the rest into the basket, and went to the bed. So he ate one third and put the two-thirds back into the basket. Let's continue. In the morning, these friends divided the remaining berries, and each one ate one third of the berries. Okay. So let's see what we're trying to do. Question is, what's the minimum number of berries the friends could have started with? Okay. Okay. And the knowns are that the number of berries were a whole number to start with, and each one ate a whole number of berries, and so the berries they all had in the morning were all whole number berries. Okay, they could only divide into wholes. They don't cut up the berries. Okay, let's continue. Approach is that x be the number of berries in the question. So we would use a variable here. Introduce a variable and multiply that by two-thirds three times. So first friend ate third, left a two-third. Second friend ate a third of that, left two-thirds of that. Third friend ate a third of whatsoever we had and put it back two-thirds. And the final result must be whole number. So there are x is a whole number, and the final result, which is number of berries each friend had in the morning, were is. We just did we repeated the section here. The final result must be whole number. Okay. So if x were the berries, then they divide by multiply two-thirds three times, and in the morning they divide again by three. Yeah. Two-thirds times two-thirds times two-thirds is 8 divided by 27, and then three when we divide again by 3 in the morning, so each friend had so many berries in the morning. And that must also be whole number. X must be whole number. This must also be whole number. And also we're looking for the minimum number of value for X. Okay, so let n be this number, which is we call whole number. Okay, let's see what happened then. Then that means 81. 3 times 3 is 9. 9 times 3 is 27. Times 3 is 21. 81 times n, which is transpose and apply here. We transpose. This was divided by term. We multiply that by on the left side. 81 times 9. N must be x times 8. Okay. So multiply both sides by 81. That's what we did. Okay. Let's continue here. So x is 81 divided by 8 times n. Divide both sides by 8. Okay. Okay. And x is a whole number. Okay. For x to be whole number, n must be a multiple of 8. N divided by 8 must be a whole number. Okay. And we're looking for smallest number of x for x, so n must be 1. N must be 8. Okay. Let's continue here. So n must be 8 and x must be 81. So these three friends started with 81 berries. Okay. There are no other smaller number than 81 which would satisfy the constraints of the problem. Now, another way to think of a problem is think of a number. Okay, here's the game. I'm thinking of a number. I subtract 20 from it and add 15 to the result. My answer is now 48. What number am I thinking of? Okay, we solve such a problems by reversal method. Okay, what is the reversal method I'm talking about? So we take such problems by reversal method. Let's see what that is. What's the reversal method? And here is the example. To return home from the mall, we follow exactly the same path as we followed to go to the mall. But we do that in the reverse order. So that's a reversal. And change all right turns to the left turns and left turns to the right turn. That means that all additions become subtractions and all subtractions become additions. Let's continue. To apply the method, we first subtract 15. 15 is the last thing we did. We added 15. So we're going to start backward. We have 48 and we got 48 by adding 15 to something. We subtract 15 from 48. Okay, okay. From that will get me 33. Then 33 we got by subtracting from something, 20. So we add 20 back. Second, we add 22, this 33, to get me a 53. So I must be thinking of a number which is 53. Let's do some exercises here. Question 1. I'm thinking of a number. I multiply by 2, add 7, and divide by 3. Now I have 9. What number am I thinking of? Okay. Here, if you look at turns here, I multiply by 2. So let's say multiply is left turn. So when we come back on the reversal method, we would be dividing by. Here's add 7. So let's say this is add 7. When we come back, equivalently, we would do subtract 7 and divide by 3. In the end, we have. So we would multiply by 3. Okay, let's continue in the reversal method. So we'll take a 9 here, multiply by 3, then subtract 7 and divide by 2. Let's continue here. Here's an example. Question is, I'm thinking of number. To that I add 1, divide by 2, multiply by 3, and subtract 6. Now I have 9. What number am I thinking of? So use the reversal method to come up with the number I'm thinking. Some equation here. Wish to solve such a problem, we represent that by an equation. So the equation, okay, and let x be the number I'm thinking of, and we say that we subtract 20 and add 15 becomes 33. Okay, so x, first we say we subtract 20, so x minus 20. I just put in a parenthesis here to indicate my order. This is I did x minus 20, and to make sure that it's clear that to that result of this thing is we're going to add 15 plus 15. Okay? So this is the equation I was thinking of. Equation has two sides separated by equal signs. So there's equal sign here, there's something on the left and something on the right. The sign indicates equality or balance between two sides. Does that remind you of a story of two cats fighting over sharing a bread and monkey with a balance to help them break the bread into two equal pieces? Let me recite the story the best I recall. The two cats were fighting over a bread they want to share equally, and they were fighting over. They went to a monkey. Monkey had a balance, which is balancing scale, and so monkey agreed to help these two little kids divide the bread into two equal pieces. So he divided the bread in two and put them on a scale. One side was heavier, so he grabbed a piece of from the bite from the heavier side, and now the other side is heavier. Now he grabbed another piece and ate that too, and finally he went on to this exercise of trying to balance the two pieces, and in the end he ate whole of the bread, and the pieces were all balanced now. His scale was balanced. So he tell dear cats, so now scales are balanced. Both sides have equal number bread, and you can the cat on left can have the bread from left pan, and the cat on the right can have bread on the right pan, and there was nothing in the pans anyway. Let's continue. Okay, in dealing with the equation, we maintain that balance or integrity of the equation. So when we're doing equations here, we do need to maintain solving equations. Solution solution of such equation involves moving all constants to the right, keeping only 1 times x on the left. So anything on the right is answer to x equals, okay? Because 1 times x is same thing as x. Let's continue. Solution for x is the right hand side, okay? Observation, in the above equation we had x minus 20 in parentheses plus 15 equals 33. Highest flag value, which is power of the variable x of any term, was 1, okay? And a constant term has a flag value of 0. Such equations are linear equations, okay? So in this video we'll consider only linear equations. Let's see how to solve the equation now, okay? To solve the equation, we apply a sutra, transpose and apply. So we are trying to transpose everything that doesn't have the variable to the right, okay? Let's continue here. When we move added term across equal sign, it gets transposed to a subtracted term. So this is my transpose here, get transposed to. If we move a added term across equal sign, it gets transposed to a subtracted term. Let's continue. When you move a subtracted term across an equal sign, it gets transposed to an added term. So this is transpose here, sutra, transpose and apply. So subtracted term gets transposed to an added term. Let's continue here. When we move a multiplied by term across equal sign, it gets transposed to divided by term. It gets transposed to divided by term. Let's continue here. When we move divided by term across equal sign, it gets transposed to multiplied by term. Transposed. So these are the sutras for transpose and apply as we get applied to solving a equations, a linear equation, let's say. When you move an added term across becomes subtracted term. When you move subtracted term becomes added term. When you move multiplied by term, it becomes divided by term. When we move divided by term, it becomes multiplied by term. Let's continue and solve a equation. Let's do example here. We have been talking so far about x minus 20. After we do x, first we do x minus 20, then to that add 15, and result is 33. X is the number I'm thinking of. To that, I subtract 20 from that. What's our result is that tells me this parenthesis here saying I'm going to do x minus 20 first. Whatsoever we got to that, we get plus, add 15 to that, and answer is 33. Let's continue here. How do you solve it? So this is the last thing we did. So we're going to subtract, we're going to move that across the equal sign, and this is added term. It becomes subtracted term. So we'll move plus 15 from left, which get transposed to negative 15 on right. Let's continue here. Now it's a minus 20 left is here. Okay. First of our right side is 33 minus 15, which is 38. Okay. And now on the left I have a minus 20, which I need to move to the right. Let's continue here. So we have, so far we have x minus 20 equal 33 minus 15, which is 18. Okay. And now parentheses, I don't really need parentheses here anymore because I have x minus 20, the first operation I did. Let's do the x. Let's continue here. Some folks would subtract 15 from both sides to cancel out 15 on left. In VM, we use the sutra and skip that extra step. Okay. So you could have subtracted 15 from both sides with cancelling out the 15 on the left, and would have 33 minus 15 on the right. But we'll use the sutra that added terms get transposed to subtracted term when we move to the right, move across the equal sign. Let's continue here. So now I'm going to move this negative 20 to the right, which is going to become positive 20. So the subtracted term minus 20 get transposed to added term plus 20 when we move that across the equal sign. Let's continue. So on the right side I have 18 plus 20, which is 38. So and on left I have x left. So x is 38. Let's continue here. So x is equal to 18 plus 20. I just wrote that, and x is 38. Okay. I do go through a number of steps here, and with practice you would start to combine steps. Okay, and let's do some examples here. X equals 6 plus 3, no transpose required. Everything that's constant is on the right side. 6 plus 3 on the right is 9, so x is 9, which just we solved that by observation. Let's continue, and this example requires 0 transpose. We did not have to transpose anything across the equal sign. Let's continue here. Here's another example. X plus 3 is 9. 3 is on the plus 3 is on the left, and we need only x on the left. So this thing has to be transposed to the right, and added term becomes a subtracted term. Let's continue here. So we just move that plus 3 to the right and becomes a minus 3. Okay, 9 minus 3 is a 6. So x is a 6, the answer. So x is 9 minus 3, extra step here, and x is 6. That's the answer here. Let's continue. So this example requires 1 transpose. We transpose plus 3 to the right, which become a minus 3. Let's continue here. Example is 2 times x equals 7. So we had x, a number I'm thinking of, multiply by 2, and answer is 7. Let's continue here. So I'm going to move that, transpose the 2 times from left, we become divided by 2. Okay, so it's a multiplied by term here, become divided by when I go to the right. Let's continue here. So x is 7 by 2. That's the answer. Let's continue. How many transpose was this required? This had only, we transpose multiply by 2 to the right, as 1 transpose was required. Okay, so x minus 3 is 13. Minus 3 is something we need to get that on the right, which means transpose. That means negative term, subtracted term get transposed to across the equal sign, become plus 3. So let's see what happens. We take minus 3 here, and which become a added term plus 3 on the right. Continue. So x is 13 plus 3. 13 plus 3, which is 16. Okay. So again, x, let's do another example. X divided by 3 is 7. So divided by 3 is, other than we only need x here, divided by 3, we got to go to right, which means move that across the equal sign. That means get transposed to multiplied by term. Okay, let's continue here. So this divided by 3 get transposed to the right and become multiplied by 3. Let's continue here. So x is equal to 7 times 3, which is 21. So we have some example where we require two transposes here. So first we had x, we multiplied by 2, to whatever that was, we added 6 to that, and answer is 13. So first this plus 6 goes to the right, we move that across equal sign and get transposed to minus 6. That's what happened. So we move that and become minus 6 here. Okay. So so far we had 2x equals 13 minus 6, 13 minus 6, which is equal to 7. Okay. So now I got to move this multiply by term, multiply by 2 to the right across the equal sign right here. That become divided by 2. Let's continue here. So that means x is 7 by 2. Let's continue. X, here's another one, x divided by 3 plus 1 is 4. So move that plus 1 to the right, which means added term get transposed to subtracted term when we move across the equal sign. Let's continue here. So this one disappear, we move that right, become minus 1. Now we have x divided by 3 is equal to 4 minus 1, which is 3. Okay, let's continue here. So now divided by 3 get transposed to multiplied by 3 when we transpose across equal sign. So on the right side we have a 3 times 3, 9. Okay. So x is equal to 3 times 3, which is equal to 9. Let's continue. So x is 9. And let's do 3 times x minus 41 equals 13. Let's continue. So first we transpose negative 41 to the right, will become positive 41. 13 plus 41 is 54. Let's continue here. That means 3x is 54. Now 3 multiplied by 3, we transpose that to right, become a divided by 3. Let's continue. So we divide by 3, and 54 divided by 3 is 18. That means x is 54 divided by 3, which is 18. Let's do some examples here. So first we add 1 to x, then so that comes up to, we multiply that by 10. Results of that, we add 5 to that. Okay. So this plus 5 is the last thing we did. We're going to move that across the equal sign, become minus 5. Let's continue here. Okay. So we get 115 minus 5 on the right. Okay. And this 5 got transposed to the right and become minus 1. Let's continue here. So that means x plus 1, which this side times 10 is 110. Okay. Let's continue. Now this 10 here multiplied by 10 become divided by 10 on the right. We move that multiplied by 10 across the equal sign and become divided by 10. Okay. Let's continue here. That means x plus 1 right here is 110, that one divided by 10, which is 11. Let's continue. Then we move the added 1 across the equal sign, become minus 1. Okay, let's continue here. That means x is 11 minus 1, which is equal to 10. So x is equal to 10. Let's continue. So, okay, let's do another example here. X minus 1 times 2 minus 3 equals 5. Okay, that means that this is the last operation we did on x and minus 3. But we move that across the equal sign and we become subtracted term becomes added term on the right. Let's continue. So we just move that to the right, become added term plus 3. 5 plus 3 on the right is 8. Let's continue here. That means on the left we have x1 minus 1 times 2, and on the right we have 8. Let's continue. Now we have to do this multiplied by 2. We got to move that across the equal sign, which would become divided by 2. Let's continue here. Okay, so we move that plus divided multiplied by 2 to the right, become divided by 2. 8 divided by 2 is a 4. So on the right side we have 4. Okay, then means x minus 1 on the left equals 8 by 2, which is 4. Let's continue. And now this minus 1, when we transpose that to the right, become plus 1. So minus 1, when we move that to the right across the equal sign become plus 1. That's it. Subtracted term get transposed to added term. So we have x is equal to 4 plus 1. This is 4 plus 1, and which is equal to 5. Do more transposes here. Here is x minus 1. First we do subtract 1 from x, then multiply the result by 3 and add 2 to the result of multiplication by 3 and get it. Result is 26. Let's continue here. Okay. First we do is this added, we added plus 2 last, we subtract that, we move that to the right and across the equal sign the added term become subtracted term. 26 minus 2 is 24. On the right we have a 24. Let's continue here. So we have x minus 1 times 3 equals 26 minus 2, 26 minus 2, which is 24. Let's continue here. Now this multiplied by 3, we got to move that across the equal sign and we become a divided by 3. Let's continue here. So multiplied by 3 became divided by 3. Okay? 24 by 3 is a number on the right, which is 8. Let's continue here. So that means x minus 1 equals 24 by 3, which is 8. That's what we have on the right side. So that now this minus 1, we move that across the equal sign and become a plus 1. Subtracted term, when we move across the equal sign, become added term. Let's continue. So minus 1 become plus 1. Okay? Continue here. So we have x is equal to 8 plus 1, which is 9. So x is a 9. Let's continue. And let's another example here. 2x plus 3 times 2 minus 6 is 8. Let's continue here. So first is last thing we did, subtracted 6. Now we move that minus subtracted term to the right, become added term. Plus 6. Okay. Now so on the right we have 8 plus 6 is 14. Now it's multiplied by 2 here, and that when we move that across the equal sign, we become a divided by 2. Let's continue here. So move that multiplied by 2 become a divided by 2 on the right side. So 14 divided by 2 is a 7. So on the right we have a 7. So we have on left we have 2x plus 3. On the right we have a 7. Let's continue. Now this plus 3 is first we do 2 times x, then to that we add plus 3. So now we have to move this plus 3 to the right, and when we move across the equal sign, that get transposed to minus 3. Let's continue. So this we get this move with the plus 3 and become minus 3 on the right. 7 minus 3, which is 4. That's what we have on the right. Okay, let's continue here. So that means 2x is 4. Okay, and now this multiplied by 2 terms, we move that across the equal sign, become divided by 2. Let's continue. So now we move that multiplied by 2 to the right across equal sign, become divided by 2. Okay, so 4 divided by 2 is a 2. So that means on the right we have a 2 so far. So that means x is 4 by 2 equals, which is 2. Let's do some more examples. Here's an example. First we multiply x by 2. From that we subtract 1. And result so far we multiplied that by 4. To that we add 2. Then results of that we divided by 3. And answer is 10. Okay. First we would move that divided by 3 is last thing we did. We would move that across the equal sign, become multiplied by 3. Let's continue here. So right on the right we have 10 times 3, which is 30. Let's continue. So far we have 2x minus 1, and which result of that is multiplied by 4 plus 2 and equals 30 on the right. Let's continue. Now this plus 2 is the on the left side, plus 2 is the last thing we did. So we move that across the equal sign, and added term becomes subtracted term, and it becomes a minus 2 on the right. Let's continue here. So on the right we have 30 minus 2, which is 28. Okay, let's continue here. So we have 2x minus 1 times 4. On the right we have a 28. Let's continue here. Now as multiplied by 4 is the last thing we did on the left side. We would move that across the equal sign and become divided by 4. Let's continue here. So multiply by 4 become divided by 4. So 28 divided by 4 is 7 on the right. Let's continue here. So we have a 2x minus 1, which is a 7. Let's continue. Now this minus 1, we would transpose that across the equal sign and will become a plus 1. Okay. So we just move that. Okay, let's continue. So the 2x plus 1 is 2x minus 1 is a 7. Okay, okay, let's see what happened. Then we move that, we come plus 1 here. 2x minus 1 was 7. We transpose the minus 1 to the right, become plus 1. 7 plus 1 is 8. Let's continue here. That means 2x is 8. That means x is 8 by 2, which is 4. Let's continue. So x is 4. Let's look at some exercises here. Solve for x in the following. Okay. Here is a x minus 4 in parentheses minus 3 plus 0 is 80. Okay. Let's continue here. X minus 5 in parentheses plus 1 in parentheses minus 4 equals 42. Okay. First we subtract 4 minus from x, then to the result of that we add 5. To result of that we subtract 3, and that is equal to 77. Let's continue here. So here is 2x plus 3 minus 1 is 8. Let's continue here. And 3x plus 4, we multiply that by 10 plus 5, multiply, add to that we add 6, and result is 3, 4, 5, 6. Let's continue here. Okay, it's 7x minus 6, multiply that by 10 minus 3. Result of that, we multiply that by 10 plus 9 and equals 6379. Let's continue here. X plus 3, that result of x plus 3 multiplied by 2. From that result, we subtract 7. And to that result so far, we multiply by 3. And to that, we add 2 and equals 29. Let's continue here. 2x plus 4, result of that we multiplied by 5. From that we subtract minus 3, and result of that we multiplied by 4 plus 1 is 269. Okay? And for more example, you can look at Glover's book 1. All the ideas presented here are from that book. If you look at Khan's Academy, you can start from here. I give you the links. Their links are valid at the time I wrote them up, and the sites keep changing links, so as such you have to look around, and maybe there's different link when you are looking around. I hope the link does not change, but that's the link when I did it. Let's continue. Usual references are teacher's manual, Tirthaji's book, and one Single's book, but most of the ideas here are from James C. Glover's book 1. Okay, let's continue.